right? One-way t-test. So let's go back to the textbook. And what I'm going to do is I'm going to do Control F again. I'm going to search. And I'm going to search for chapter 17. And it's going to come down. First going to talk about chapter 17, and then it's going to actually get to chapter 17, right? Inferences about a population mean. And here's where we talked about t-tests. We covered the conditions for the inference, the t-distribution, the one sample t-confidence interval. We covered all this in the lecture. It's covered again in the textbook with different examples, more information, and this is going to help you understand it better. So study this chapter, and what you can do here, once you get to this chapter, is again, you can just type in the search bar. See where I got the search bar up here? And you can type in check your skills. I mean, read through the chapter, but also if you've already read the chapter and you feel like you understand it pretty well, go down to this check your skills section and look at these questions. We prefer the T procedures to the Z procedures for inference about a population mean because A, Z can only be used for large samples. B, Z requires that you know the population standard deviation, mu, or beta. Z requires that you can, oh, sorry, not theta, sigma. Z requires that you can regard your data as an SRS from the population. What's the right answer here? Why do we prefer the T procedures over the Z procedures? We talked about it in the lecture. It's covered in the text of the textbook, right? Remember that with Z, you need to know the population standard deviation. And we pretty much never do. So using the Z-test isn't something that we use a lot. In fact, we didn't really talk about the Z-test that much because it's hardly ever used. So look at this question. You are testing the hypothesis, the null hypothesis, mu is equal to 10, against the alternative hypothesis, mu is less than 10, based on an SRS, simple random sample, of 20 observations from a normal population. Well, this sounds familiar. This is something that we've heard of before. The data give X bar, which is mean, equals 8, and S, standard deviation for the sample, is equal to 4. The value of the T statistic is, okay, now here, I'm not going to ask you this question. I'm not going to do this. I'm not going to ask you a question that makes you have to calculate the test statistic unless I give you the formula. Okay, if I give you the formula, I would do it, but I won't ask you to calculate the test statistic unless I give you the formula. But I would give it to you. And then I'm not going to expect you to know the p-value because I'm not going to give you a lookup table because we didn't go over that, and we're not going to use R in the final. So I wouldn't give you those questions. This would be a question that would be more likely I would ask. Which of the following would be most worrisome for the validity of the confidence interval you calculated in the previous exercise? So this more tests the concepts. So what would be a problem, a real problem for the t-test? The presence of a clear outlier in the raw data, a mild skew in the stem plot of the raw data, not knowing the population standard deviation. You guys all know this by now, right? What's the answer?
C.
C, not knowing the population standard deviation. Okay, well, okay, no. Think about it. Remember the assumptions for the t-test. Strong outliers make the data strongly not normal and would mean that the mean is not a good measure of the central tendency of the data. Therefore, a clear outlier in the raw data would have a really negative impact potentially on the validity of the t-test. Not knowing the population standard deviation isn't a problem for the t-test. You don't need the population standard deviation. You just need the sample standard deviation. That works. Read the chapter. Read the chapter. This one should be familiar for you because we went over the matched t-test a lot, right? Which of these settings does not allow use of a matched pairs t-procedure? You interview both the husband and wife in 64 married couples and ask each about their ideal number of children. You interview a sample of 64 unmarried male students and another sample of 64 unmarried female students and ask each about their ideal number of children. You interview 64 female students in their freshman year and again in their senior year and ask each about their ideal number of children. So one of these is not a matched t-test. Which one?
B.
B, right, exactly. They're not matched. They're like separate groups that have nothing to do with each other. The husband and wife pair, they're somehow matched. There's a pair, a couple. And then the 64 female students are measured before and after, just like our pulse, right? Okay, so you're thinking logically. Good. Think logically with what you know, and you'll get this. And because the T procedures are robust, the most important condition for their safe use is that A, the population standard deviation is known. Well, obviously not, because we already decided that wasn't what really matters. The population distribution is exactly normal. Remember, the word robust in statistics means that the assumptions don't have to be exactly met and normality can be sort of, right? But if you have a sample that's not random, if you have a non-random sample, then you've biased your data and your conclusions are probably not going to be valid, right? Now let's go on to chapter 18 to the 2A t-test. Okay, so comparing two means. This we spent more time on, right? Comparing two means. And again, if you're here, and then if you search for the check your skills, you come down and you find this section on check your skills. And here are a bunch of multiple choice questions, which I thought would be great to just copy and paste right into the test. Because I know you can figure out the answers because it's all in the book. And I'm not going to give you stuff that I didn't talk about at all. You know, I also talked about it in my lectures. Here's one that talks about food. We like food. How many calories does a fruit juice popsicle labeled no sugar added pack? It doesn't have sugar. How many calories could it possibly have? A random sample of 10 popsicles of a particular brand is selected and the calories per serving are measured. Calories per serving. We've done that before. To get a confidence interval for the mean calories per serving of all no sugar added popsicles from this brand, you would use the one sample T interval, the matched pairs T interval, or the two sample T interval. A, right? We've got one sample. We have one sample, so it's got to be the one sample, right? It's not going to be that hard. Everybody's going to do great. There, a study is designed, okay, this goes, a study is designed to compare the amount of vitamin C in milligrams per serving in oranges that reach the stores either 1 day after being picked or 3 days after being picked. A random sample of 15 oranges is taken for each group. To test whether there is a difference in the mean vitamin C amount of all oranges reaching stores either 1 day or 3 days after being picked, you would use, what's the appropriate test, right? Think about it. You can figure this out. One sample t-test, the matched pairs t-test, or the 2 sample t-test. Well, first of all, do we have 1 sample or 2 samples?
That's fair.
Well, we definitely have 2 samples, but are these matched pairs?
Same fruits.
Same, not the same exact fruit. It's there's 15 oranges that were picked that were measured 1 day after being picked, and 15 oranges that were measured 3 days after being picked. It wasn't measured 1 day and then waited 2 more days and measured them 3 days after. They're separate samples. I know the matched pairs is tricky, but think about it. Are they a pair? Are they measured before and after? Are they connected in some way? Yes, the same kind of fruit, because it would be kind of weird to do apples and oranges, literally comparing apples and oranges. Okay, so review this chapter, review my lectures, and these answers will be clear. Okay, now you know exactly where to look. These are the questions that are on the test. Not all of these questions, but a lot of these questions. This is where the questions come from.